Good morning, all participants. Assalamu alaikum. Let me introduce myself. I am Hilali, professor, retired, Bangladesh University of Engineering Technology. I working there last 37 years, from lecturer to professor. I am working last 2 years with the fire safety code and fire safety issues. Now I like to give my presentation on Bangladesh Building Code BNBC 2020. The topic on the Bangladesh Building Code 20, this is part 4. The title of this part is Fire Protection. Today I shall talk only with the chapter 1, 2, 3 and some part of appendix. Next day I will talk other parts, other chapters of part 4. The objective of this training is to educate participants on the fire protection part of Bangladesh National Building Code 2020. To start with mission code, I like to share with some fire issues, how a fire moves or how a fire behaves in a building. Actually, it's a building code, so we will talk only with the fire inside the building. Inside the building, where a fire initiates, you can see it will propagate very fast and the temperature rise very fast. Within 2 minutes, it will flash over, and it varies with type of contents in the building. It may be liquid fuel to any substance. So the fire propagation time varies from 22 minutes to 10 minutes to reach this flash over. So whatever I like to design or you like to design, you have to design keeping in mind that the temperature will rise up to that limit and within this time. If you think about the life safety issues, so whatever you do, you have to do within 10 minutes. If it is beyond 10 minutes, it will be very difficult to save life from that compartment. So with the life safety issue, there is another thing is property issues. So here you can see fire propagation into the building and the destruction curve of property destruction. So here you can see within 8 minutes it will flash over. When it flash over, already about 50% is property has already destroyed, destructed. Within 16 minutes, 100% property of that room will destructed. So if you like to save, if you have to design, you have to keep your mind on this basic thing, how fast the fire will move. There is something different if the fire is an explosion. Then it is very, very fast. In that case, we have nothing to do. So in that case, we fight differently. So while designing BNBC, we think there we have some assumptions. First thing is our fire is a normal fire. It will propagate within 2 to 16 minutes in the building. After 8 minutes, it will cross the boundary and it will give this destruction. With this assumption, we will design our building, our life safety issues and property safety issues. Now, Bangladesh Building Code. Actually, Bangladeshi Building Code was gazetted in 2006. Before that, there was a Building Construction Act in 1952, and it was updated in 2006. In reality, this was proposed in 1993 after a lot of discussion, a lot of corrections and modification. It was accepted by the government in 2006.
Professor
After
Hirali,
that,
sorry to interrupt, but আপনার মাইকের ভলিউমটা বোধহয় একটু কম আছে। আপনি মাইকটাকে একটু কাছে এগিয়ে আনতে পারলে ভালো হয়।
is it now fine?
It is better now. It is better now.
Okay, thank you. So in 2006, Bangladesh Building Code passed by the government. In 2010, there was a committee to update this Bangladesh Building Code, and it was submitted 2013. After that, in 2021, it was again gazetted, which is called BNBC 2020, though it is passed in 21. The BNBC has some basic concept. To start with this, before going to the part 4, I'd like to introduce some basic points which regulates the building code. If I read slowly, the provision of this code shall apply to the design, construction, use, alteration, moving, demolition, repair of any building or structure, and to any appurtenance. If for any case, different section of this code provide different specification, the most restrictive specification shall govern. As for example, if there is something debate with the part 4 and part 8, actually part 4 is fire prevention, in part 8 is HVAC or other things. There are some conflicting data sometimes because different people write that one. In that case, the most restrictive specification will govern. And the third one is in case of any conflict between the general requirement and a specific requirement, the specific requirement will prevail. In being part 4, there are some requirement, it's general requirement, and there is something in the special requirement. If something gives some conflict, we have to select the specific requirement one. Another thing is the provision of any appendix in this code shall not be mandatory unless they are referred. Another thing is neither the authority nor any employee thereof shall be liable for permission under the provision of this code. If the authority give permission, if there is any fire, if there is accident, that does not affect who is giving the authority or permission. So these are the basic, some understanding of the BNBC. Now I like to go to part 4, which is the main topics of me. This part have general provision, some precautionary requirements, then the means of egress. Today I shall talk with these 3. There is another 2 chapter, equipment and building facilities standard, and the requirement for the fire detection extinguisher system. These 2 will talk tomorrow, and relative appendix. So I shall talk now with some general provisions and the precautionary requirement and the means of egress. These are mainly life safety issues. These are not fire protection issues or firefighting issues. So these are very, very mandatory, which has to be followed. In chapter 1, there is some scoped terminologies, general requirements, fire drill, fire test, and fire resistance rating, the appendix. So I shall start with that. General requirements, terminology scope will come. You can read, you can understand very easily. The general requirements, actually, you have already learned. There are some height and area limitations, which is in part 3. It's a structural part, and most probably some architect has given some lecture on that. Second thing is open space requirement. This is also architectural part, is in part 3. And the access facilities for the fire service, this is also in part 3. That is also have lecture. Fire drill and fire test, today I shall talk. Though we have already learned the height and area limitations, I like to show a table to give some indication how it is related to the part 4. This is a table giving you the height limitation based on the road width and the front space. So there is two axis. One is road width, another is front space spindle. Then there is another third axis which give you the type of the building during the construction. That is related to my lecture. That is, all building is classified based on their fire rating of the elements, the structural elements. Depending on the structural element, building are typed in two categories. One is type 1, another is type 2. I will come detail after that. But here I like to show that there, for different types, there is height limitations. So if you like to go for more than 6-story building, you have to be in a type 1A or type 1B. If it is less than, then you can choose 1C, B, or the type 1 is non-combustible material. Type 2 is combustible material. So this is the variation. I will come detail with the type 1, type 2 later. Just here to show the height limitation. So if you have some height limitation, or if you like to go high-rise building, you have to choose accordingly. You have to consult with this table, which is not in this part, which is in the part 3, but is highly related to part 4. Fire drill, this is a part of this. This is more definitely in the appendix. So here I will not say it very elaborately. I talk with the appendix, then I will give some elaborate idea about the fire drill. Here I am just giving some points. It is first aid firefighting. It deals with the first aid firefighting. First aid means which is done by the inmates of the building, not the professional firefighters. That is the hydrant system, which can be handled by the inmates or the inhabitants of the building. They can fight primarily. We call this is a first aid firefighting. It can be with the hydrants, it can be with the portable fire extinguisher. The relocation of the population that is related to the fire drill. Relocation means when there is an incident of fire, the occupant should be relocated or evacuated. According to the facility, according to the building design, it can be evacuated or relocated for the first time so that they can be safely way out. Then lastly, the orderly evacuation, which is guided by the laws, which then you can see how orderly we can go out at the time of incidents. I will talk later because this is an appendix. Appendix is not a mandatory. It is supporting. Then this chapter contains something with fire test and fire resistance rating, which is very deciding. Here is some standards. I shall talk a little bit detail with this standard, how they are tested, how the testing can be explained. So you can see here is some astm E119. Using this standard, we test the structural element and the structural assemblies. It's a element as well as assemblies. Sometimes it's very difficult to test in the assemblies because the assembly size is different, sometimes very big. So as per ASTM 119, you have to do as an assembly directly. So it is very difficult to fit a assembly in a furnace. In that case, you can use the mathematical rules, which is in ASCE 29. So indirectly, ASCE 29 is a mathematical basis to get the fire rating of the structural elements. ASTM is the actual method by which we test. And secondly is ASTM E136, which will give you the definition of the combustibility and non-combustibility. So you have to understand how to define a combustible and non-combustible. That is according to the 136. I will go later in detail. And for your surface material, finishing material, you need some flame resistant rating of the material that is tested in ASTM E84. There are different methods of testing this. ASTM E84. I will give some idea how it is tested. Another thing is ASTM E152, actually, which is replaced by ASTM 2074, but in the BNBC, ASTM 152 is referred. The modified or replaced one is not referred. So if you like to read now, you have to read the ASTM 2074. This is how fire door or windows are tested. In reality, sometimes we do not use ASTM, but when you read the ASTM, sometimes it will refer to an FPA. NFPA 252 is a standard for testing doors. NFPA 257 is the standard to test windows. All the same, but a different type of a standard. NFPA 252, 257 is similar to the ASTM 152 modified by 2074. These are the testing methods for windows and doors. So you can see the ASTM E163, which is testing standard for Windows, which is replaced by E20510. Then the last of the fire resistant rating of the structural elements are provided in the table 411. That is taken from the ASCE 229. Actually, sometimes when I come to the table, I will give you some little bit details about the ASCE 29. So now I like to show the how ASTM 119 and others are working. This is table 411, is a fire resistant rating of the element, which is just explained in the ASCE 29. This table is taken from that. If you see the table, you can see the different type of concrete element and their composition and their fire rating, the thickness of the element and the corresponding fire rating. So you can see if it is 4 hour, about 7 inch to 5 inch the thickness, and for 1 hour its variation is 3.5 inch to 2.5 inch. This is for concrete aggregate, and gradually you can see the other elements also. Here you can see the brick, but unfortunately this is all are hollow brick. Somehow it was missed in the BNBC. Solid brick is no data about the solid brick, but it is given that if for the details you can see an ASCE 29. So anything data you need for the solid brick, you have to go to ASCE 29 because it is referred by BNBC for detail of other properties of the brick. This is something missing from the BNBC for the solid brick. In Bangladesh, we mostly use, more than 99% we use solid brick. Now we are gradually moving to hollow brick or unfilled product, but at this moment, we are mostly with the solid brick. Unfortunately, solid brick data is absent from this BNBC. So for that, you have to go ASCE 29 again. How ASTM 119 tested? They have two types of tests. One is fire endurance test and another is host system test. Actually, fire endurance test is done when a member is under load, and that load, it was subject to at a certain temperature in a furnace. That load, at what time it will collapse. That is decided, that is tested in this as the ASTM. So there is a load parameter on this structure, and there is another is temperature variation within the furnace, and I can show you what is the how the temperature pressure varies. So you have to, when you do the toast test, you have to load the member, and you have to measure the transmission of the hot gas of the assemblies, and this system give you the information of the fire hazard generation of smoke, toxic gas, other products, degree of control of masses of combustion product of smoke, and behavior of the joints between the building elements. Because it's an element, it is placed as a whole of the structure and with the joints, everything. And when it is subject to its load, which is it will actually take, and how it collapses when the temperature rise. This is the temperature rising curve. So you can see, if you like to give a 4-hour rating, you have to heat it up to the 2000 degrees Fahrenheit. If you like to have 1 hour fire rating, you have to heat it about 600 degrees Fahrenheit. So the fire rating is not only the time of heating, it's also at a particular temperature it will like. If it is temperature is, if it is 4 hour, you have to rise the temperature 2000. If it is 2 hour, you have to rise it about 1800. If it is 1 hour, you have to temperature rise it 1600. If it is less than, this is the temperature variation. So this is not on the fire rating with an hour. Actually, inherently, there is another parameter which is the rise of temperature. Actually, it is withstanding. The similar curve also have given by the NFPA 252, which is again same, almost it's a totally same type of time curve, time temperature curve. So when we test all these elements, we consider the temperature type, and as you understood before, it's a load again, because you have seen there is a endurance test, another is host system test. Actually, endurance test is the loading, and host system is the a horizontal pressure will create on the testing element by steam of hose, because it may happen that when there is a fire, a hose system will give pressure from inside, so such that the structure will not collapse under the pressure of the hose stream. So when we test 3 hour, 4 hour, 1 hour, that means it will withstand a endurance strength, and it will withstand a hose slip pressure, and similarly it will withstand a definite type of temperature. So I think you have understand that actually the testing of a rating of the material or the element or the structure is not only the temperature, not only the hour, it is load, pressure, of things. So when it actually tested, it given all these thing parameters are tested and reported. Now I like to talk a little bit of ASTM84. Actually, ASTM84 give me the two things. One is flame split index, which is a number or classification of indicating a comparative measurement. It's a comparative measurement, comparing with some standard thing. Is a red oak. How does the red oak behave? All the elements will relate compared with this red oak, and that it will give you a number. It's a relative number with that. It can be in the percent or it can be in the time. From observation made during the progress of the burning of a zone of flame under definite test condition. Actually, in a furnace or in a tube, a part of the element, a certain length of the element is introduced, and it is subject to a definite temperature. And the flame will propagate. The flame front will move from one point to the other. How does it propagate from tip to the certain distance? That is measured with a definite standard oak sample, and it is quantified, and it will give you some flame spread index. Another thing is smoke development index. It is again how much smoke is generated with a same element. It's a oak sample. The amount of smoke generated is measured by its transparency. The transparency of the smoke, you give some measurement, a relative measurement, and it will give you some index value that will give you some understanding the any material how much smoke is generated, but it does not measure the toxicity. It measures the density of the smoke only, and this will give you some index value. So this rating is about 25 to 500. 25 means it's very, very retardant. That is the concrete. It is 500. That is very high. It is a very, very fast moving flame spread. Sometimes it is giving a class 1 value. Sometimes it is says class A value. The two procedures I use. Somebody says it is class A. Somebody said it is class 1. The same thing is actually it's some rating value. Sometimes it's giving a number 25, and the highest number is 500. So this is the rating value, flame spread rating. And smoke index again is a 0 to 100. 0 is a concrete, is asbestos, and 100 is the red oak wood, which is 100. So comparing these two, all the surface finishing element or the combustible building finishing element used in the building is rated, and accordingly it will be used for different building for the inside finishing. Last thing I like to talk is the ASTM 136, which you give some idea what is non-combustibility and what is combustibility. You know, at certain temperature, everything will boil. If it is steel, it will boil. It will vaporize. But again, it is non-combustible. So, what is combustible? What is non-combustible? It's a very deciding definition you have to know. So here is 3 types of different definition. First thing is material, no part of which will ignite and burn when subject to fire. So there will be some fire, it will not ignite or burn. Second thing is, if the material is a composite, that means actually now we are using a lot of composite. If the base material is non-combustible, if it is coated with something, if it is flammable, if it is heated up to 750 degrees centigrade, if it is allowed for 5 minutes, the vapor it will liberate. If it is not flammable, then it is non-combustible. I repeat again, a material which has a base structural element which is non-combustible, but if it is coated with something, if it is less than 180 degree thick, and if gives some vapor, and that is not flammable, then you say it is non-combustible. If it is continue flame, ignite, and then it will not non-combustible, it will be combustible. So you have 3 different things. One is which is directly ignite, and another is which is subject to certain temperature, 750 degrees. Say why, you can ask that why it is 750 degrees. Actually, in our building, the temperature rise whenever there is a fire is within this limit. In before 1950, this definition was different. This temperature was 1250, but now it standard changed its value. Now it is 750 degrees centigrade. If the temperature rises to 750 degrees centigrade, if the material gives a flammable gas, and if it is initiate burning, then it will be combustible. If it is not, then it will not. And so you can understand actually combustible, non-combustible. So now I like to go for chapter 2. I have just finished the chapter 1, will be in which part 4. Now I go to for the chapter 2, which will give you some idea about the precautionary requirement which you have to do for your building. So before going to that, you have to know some building occupancy classification, classification of the construction type, fire zone, and with separation. And there are some other things here you can see. So I like to go with the occupancy classification. Just you have already have some idea, which you see in the part 3. So this is whenever you have to give fire separation, firefighting, all anything onto that, you have to. It depends on it's how what is the use of this building. What is the use means how who will occupy the building and what will be done in the building. So accordingly, the building is classified depending on the occupancy. Occupancy is the type of occupant is you're using it or type of process or type of thing you are doing it inside the building. So it is classified in that way. The residential, we call it A classification, occupancy A, and the educational is B, the institution is C, health care is D, and business E, mercantile F, and there is some other sub classification you can see. And there is a G, which is a industrial building, then the H is a storage, I is the assembly, J is the hazardous building, and garage, utility, and miscellaneous. Actually, these are the name is taken for the BNBC, but if sometimes we need to compare with the other international laws as per NFPA, IBC, or India standard, actually almost every case there is some variation. In the base in Bangladesh also we have another law, the Raju Nirman Bidhimala, which has also this type of occupation, and there is some variation with Raju Nirman Bidhimala and BNBC. So if you like to compare with these our Rajuk law or our BNBC, you have to be very careful actually what occupancy you are considering, because our basic idea of occupancy is different in different areas. As for example, in Rajuk Bidhan there is no subgroup B3 preschool facility. They are only 1 and 2. At the same time, in the institution, in the C, in the Rajuk Bidhima, there is no C. Another thing is, I like to very specifically say that that is very difficult to understand. That is the healthcare facility, is the D1, D2. Here it is written as a normal medical facility in our BNBC, and due to we say it is an emergency medical facility. It's difficult to understand between these two. Before going in detail, little bit detailed, I like to show the Raju Vidimala also just for your understanding. Shastro Sheba D is a D1, is a hospital, clinic, nursing home, diagnostic center, and laboratory is a D1. The D2 is the emergency medical facility center. So you may understand that hospital, we always know there is some emergency center. Without emergency, no hospital can work. So what is the difference between this hospital and the D2, the emergency medical facility? Is it the same or different? It's a very difficult question. Nothing is elaborate in this Rajuk Vidhimala, but in BNBC, we have little bit idea of the difference. It is two. You can see that not detail, but it is taken that you can see normal medical facility, emergency medical facility. What is mean by normal medical facility? Actually, hospital is a normal medical facility, and hospital has an emergency medical center. So, actually, in detail, you can see that D2 emergency is not medical emergency. If in the nation some emergency arises due to the earthquake or some other thing, each government has different provision of fighting this emergency, then this hospital will be used. So this D2 hospital is made totally differently other than this type of hospital. So emergency medical hospital is totally different than the normal medical hospital. Both may be the same hospital, but it will build totally differently. This is very different. Another thing I like to explain a little bit about the BNBC now. This is G industrial building. Here you can see G is there is a G1 and G2. G2 is a moderate hazard building. Actually, I am talking in this area because we are a lot of work going on in Bangladesh now with garments factory. As per BNBC from 2006, garments industry is classified as modern hazard industry G2. But now it is 2020. You can see garments is not G2. It is G only. But knitwear is G2. But it's very difficult to understand why garments now it is G, not G2. It is explained in that way. It is not explained, it is understood when is writing this building. It's that actually garments have different types of commodities within the building. Some have very highly hazardous and some is moderately high hazard, some are very low hazardous. So it is very difficult to say all garments in G2. So because in that respect, actually when we give firefighting options for garment victory, we always prefer is as per 2020, it will be performance based because there is a lot of variation of fuel quantity, hazardous ability, audit a lot of that. So now, as per 2020, garments is classified as G only. So you cannot do directly Z2, but as it is not preferring in BNBC 2020, you have to think little bit differently. Some of the garments may be G2, some may not be. So you have to consider this one. Another thing I like to say, as per NFPA, they do not say garments is a G2 or G1. NFPA saying industry is classified by in that way, they come with the number of population worker working in it. They do not say hazardous directly. They give a general industry, that is the garments, not say garments. They say if there is a worker more than 150, they NFPA say that it will be a general industry. They have some other industry. They do not specify which one is other industry. In that way, they classify industry in one way. NFPA classify in industry in the other way also, depending on the hazardous. So actually, industry NFPA classify industry in two other way. One is depending on the population and the depending on the hazardous material. But BNBC does not consider number of population. So there is something different from the NFPA and BNBC. I am talking with the NFPA because sometimes a lot of our engineers and Bangladeshi engineers use NFPA as their code and their guideline, particularly Alliance Accord, Nirupan, they use NFPA, their basic. So you have to be careful about the industry, how they define, how they organize. BNBC now is using for G1, they specify if there is more than 100 worker in the building, you have to consider as a performance-based solution. You have to think for the performance-based solution, not directly G1, G2 in that way. So this is the special thing. It is until 2020, you have to think each little bit differently. So I give you some ideas about the variation of this BNBC 2006 and 2020. Here we have already talked about the Rajok in the sometimes you have to go through this classification for your understanding. Now I like to talk something about the classification as a construction type. That is again a very deciding factor for building fire safety issues. Previously, as per 2006 BNBC, building was classified in types of 4. Type 1, type 2, type 3, type 4. No subgroup A, B, C, D like this. It was totally different previously. That was something same about the Indian standard. Indian standards for Indian standard, they classify building depending on their structure in type 1, type 2, type 3, type 4. they says type 1 is 4 hour, type 2, 3 is type 3 hour, type 3, 2 is 2 hour, type 1 is 1 hour. Nothing said about the combustibility or non-combustibility in BNBC 2006, which is similar to Indian standard. In 2020, it has totally changed. There is a major change in this area in 2020. Now it is classified into a two basic standard group. One is group 1, another is group 2. Group 1 is a non-combustible material. The non-combustible does not only mean it's a concrete brick or steel. It may be many other more other things. So you have some understanding, I think, about the non-combustibility of the material. So you have understand the material doesn't burn. At the same time, a material can burn a very good, and again it can be non-combustible, as the definition I have already shown you that which is non-combustible. Another is combustible, which is wood and some other things. So in the type 2, we consider all the combustible material. In the type 1, you again see that type 1E, that is unprotected. What does it mean? That means mostly actually it is dealing with the steel structure. Steel structure as it is still is using now, it is unprotected because it's still at a temperature 1000 degrees centigrade or less than that, it still will collapse automatically. At this temperature of 650, almost all building still lose their half of their strength. So at the temperature, at the room temperature, which rise roughly 750 to 800, all steel structure will collapse with any delay. So normally a steel is using, we say it is unprotected. So any structure with steel normally say it is unprotected, but you can, if you wish, you can make it protected 1 hour, 2 or 3 hours as designed, as coated, as you can coat a steel differently with low cost to high cost, different type of material. So you can use a steel with perfectly protected material. So if you use protected material, then it will go up to other fire protected element as it. So steel structure you have to dig differently, think differently according to fire rating you use for the steel structure. So the steel structure can be of type 1 A, B, C, D, E, everything depending on the how much fire protection you use on this thing. But if it is bare material, if it is now you are not giving protection anything, it is as unprotected. So from this understanding, you may think a type 1A building has everything 4R protected. No. If it is a 4R protected building, all element is not 4R protected. Then again, you have to another table. I will show you that. This is the table. It is type 1, type B, type C, type D, type D. Actually, some of the, you can see from here, some of the element of type 1A material, it is 4R. At some of the element, it is not 4 hour, it is less than 4 hour, that is 2 hour, half hour. There are different of fire rating. So a type 1A building, the key component, the majority key component which is bearing the load, those are 4 hour. Other than those which are not load bearing, that may not be 4 hour, that may be half hour, 0 hour. You can see it from the table. So if I say a building it is 4 hour rated, that does not mean everything is 4 hour. It means some of the key component of that building is 4 hour. That will give you a type 1A building. That means it is key component is 4 hour. Other than key component or other than load bearing component, it is less than 4. And previously you can see, you can memorize that. Actually, if it is a type 1A building, you can make the building as its height limit is there in the low limit. You can make a building as high as you wish. So if you build if you wish to make a high-rise building, which is as per BNBC definition, which is 33 meter high, you have to make it is type 1A or type 2B. Type 2B, it is 3 hours. You can again see that the key component of the type 1B is 3 hours and some of the element is not 3 hours. So I think you understand that this this thing. Though basically I am talking is a 3 hour, 2 hour, 4 hour or anything. Actually, some of the element does not all the 3 hour, 2 hour. So key component are 3 hour, 2 hour. In the basis of the key component, building are classified depending on the fire rating of the construction. So there is all this up to is all are non-combustible. Here is something, these are all combustible. So though wood is a combustible thing, but if wood is more than 1 inch thick, it will give 1 hour rating. If it is 2 inch thick, then wood thick wood is more than 2 inch is will 2 hour fire rating. Also, actually, wood can be of higher rating 2 hour, not more than 2 hour, depending on the thickness of the wood. It fire rating may be 2 hour or other things. So you can see if you combustible with using combustible material, we can make type 2A or type 2B type. So these are all building with different type of rating. So though it is a combustible, it has some rating 2 hour to 1 hour. So combustible material can be used for up to this type of fire rating. Sometimes we have some idea that we can use it for as a wood as a door for fire rating, but it can be used. Wood have fire rating, and we can use a sufficiently thick wood door for particular fire rating. No, it is a combustible. So this is some idea about the fire rating of the elements of the building. So now I like to talk something about the fire zone. Actually, previously Bangladesh does not depend on the fire zone. Every zone there is a mixed occupancy. In Dhaka, there is no definite fire zone. Now there is a fire zone 1, 2, 3. Those who are dealing with some building design, there is some area of the Bangladesh Dhaka. There is zone 1, zone 2, zone 3. So you cannot make anything any zone. For industry, you have to go for zone 2 or zone 3. But for zone 1, so if every zone has a different location, then differently you have already Dhaka municipality have subdivided different zones, and building will be constructed at the different zones differently. So you cannot mix up now, but previously it was different. Now you cannot make any building anywhere. You have to go your building as per your occupancy. You have to design. So in the table there is what type of occupancy can make or what type of zone is there available. So that is not very elaborate. So you understand there is zone 1, zone 2, 3, and depending on your occupancy, you have to build your building at a different zone. Now I like to talk about something is mixed or separate or detached occupancy is a very deciding area. Deciding area. You have to understand. You need to understand this thing very carefully. Last few days before Naranganj, there is an accident. Actually, that was a mixed occupancy, and the mixing was not proper, so that the fire propagates very easily, which is unfortunate. So actually we start with the mixed occupancy, but as per NFPA, they start with the multiple occupancy. Then after the multiple occupancy, they divide is a mixed and separate occupancy. So if I talk in that way, the building which has different type of occupancy, it is a multiple occupancy. Different type of occupancy will be there. So if we subdivide the multiple into two, one is mixed, another is separate. Mixed means different occupancy will stay in that building. That is it's amalgamated. That means it is mixed, but that will be separated in such a way the critical occupancy will govern. So everything will be designed depending on the critical one. As for example, if I building, I have a residence, I have a assemblies. That means I have some other office. Assembly has some critical data. So depending on that, or if I allow all these three living together, I have to design everything depending on the assembly. That is the idea of mixed occupancy. I repeat again the same thing. Mixed means a different type of occupancy will be amalgamated in a single building. there will be no preferred separation, because I will design everything with the most critical one, taking most critical one. As for example, if I have a building with residence, with assembly, with office, then the assembly has the all critical values, higher rating values, higher. So if I use the higher rating everything, that will give me a higher cost. I am so as I am meeting all the higher rating for this, so no extra separation is needed for that, and we called it as a mixed occupancy, not a separate occupancy. So second thing I will call again, what is separate occupancy? So if I have the three, again, the example, residence, assembly, and the office, I make an area which is assembly, and I will separate it differently. So there will be no mixing of residence, no mixing of office with the assembly. So everything is separated by is higher rating protection wall barriers. Everything will protected separately, and we are building. Building is same, but it is compartmentally separately designed, separated from fire, separated from the smoke. Then it is separate occupancy. Building is same, occupancy is separated. That is a separate occupancy. So this is again a mixed building. It is not mixed building I am talking. It's a multiple occupancy building, but with a separate fire separated. So first one is mixed with no fire separated. Second one is separated, fire separated, and the third one I am talking with the detached occupancy. Detached means one is totally detached, meaning a building very close to another, or maybe not close together, is in the same premise. So these two building is detached. So you can ask the question: detached means how far it is? It may be 1 foot, it may be 3 foot, it may be, but it is detached. There will be something gap, or sometimes there will be no gap, is a very thick wall. Then it is detached, totally separated, it is detached. So in BNBC, there is no definite table about this detached table. So I will show you a table from the IBC, which will give you a detailed idea of the how detached will be made. So I will come again to this. So excuse me. I hope you have understand these three things very clearly. You have to actually, in lot of areas in our country, in everywhere we use mixed occupancy. You understand last few years, last after 13, the Dana Plaza accident, garments industry face a lot of problems because almost all garment industry there is shopping center, particularly in Dhaka. In the same building there is office, there is shopping center. In the above that is a garment. Somebody is people also residing in the same building. So these are all a mixed up. So and absolutely first, most of this building was said no mixing is allowed, though it was as per law it was allowed, but government for their safety they put some pressure on this industry building, government building. They remove all the building, particular though is allowed as per law. It is allowed because if I give proper separation with the governments or the others, it should be safe and it should be allowed. But something has happened, already gone. So what has gone, it's gonna not can be. We should not talk about that. What is now prevailing is that in also garment industry there is a office, there is a storage, there is working people in the same building. So this is again is a mixed. So if this is mixed is allowed now, why not back? Actually, we have the wrong idea about the mixing, no wrong definition of the mixing. So it's a, that time it was raised that about the tenancy. Who is the owner of that building? Who are the owner of the factory? So there are some combat within these two. Finally, it was separated perfectly. Now I like to show some table which will give you some detailed idea of how a mixing can be allowed. You have to be very careful about the mixing because it will give you some wrong idea, wrong definitions. One thing you see here that if a building is hazardous occupancy, it cannot be mixing. It cannot, because it is a hazardous. What happened last week in Narayanganj? The building has some hazards, had some chemicals, had some oil in some fuel, which was mixed with other industry. Hazardous occupancy cannot be mixed. It's very clear. Hazardous occupancy cannot be mixed with other. It should be separated. It should be detached. So building structure isolated by fire separation distance shall be designated as a detached building. So you have to detach that one. Now I like to show the another table. So you can, there is a table which is in BNBC. So it is very difficult to see from your side now. So I give some color so you can see very easily, little bit bright differently. The same, it is not as for BNBC, that is it is taken from the BNBC and colored in differently. So you can see from here the red color, which is not permitted. So if you like to meet this building C4 or D2, almost no building can come side by side. So it has to be detached with other structure. So if you can see it, other than red one, if it is yellow, it is you can see it is not applicable for D2, not acceptable. One is not permitted, another is not acceptable, or almost similar. Not permitted, not acceptable is not almost similar. But for other color, you see 1 hour protected, 2 hour protected, 3 hour protected, 4 hour protected. These are the things. So you see, if you put all these building together, you have to give proper separation. If you do not give separation, you have to make the building with the most critical one. So you understand. So when you ever like to put a, as for example, D1, if you like to make a hospital, D1. So if your hospital has some medical college attached with it, that is B1 or B2. Think about the B1, B2 and the D1 hospital, then you have to give 3 hours separation. So if you like to make a building, hospital and the medical college side by side in a building that is prevailing in Bangladesh in lot of areas, then you need 3 hours separation. But I did not see any hospital, medical college which is working private here, they don't have 3 hours separation. They are doing wrong thing as per BNBC. They should be careful about their firefighting system because they are not allowing this 3 hour separation. So I hope you understand this critical thing. Now I like to see something about the Dtest. So this is one example for this is a example, not directly proper example. Actually, you know a FR tower which burned in the Banani. Actually, fire very quickly moved from one floor to another. That is due to the improper separation that I am showing with the arrow. Actually, there is a zero power separation, zero separation. If there is a fire in the lower lower floor, the fire will move with this area, the gap, with zero vertical separation. Actually, there should be no building with zero fire separation. At least 2 or 3 hours fire separation. You have already seen from the table. I just finished last few minutes. So there is some separation with wind floor, first to second floor, because that table will give you a vertical separation and horizontal separation. But in this case, there you see the glass tower, which is very common in Dhaka, particularly in Banani Gulshan area. There's a lot of huge high-rise building with glass. Almost all buildings don't have fire separation. Almost all is a zero fire separation. This is very dangerous. That happened in the FR tower with the zero separation. So you have to be very careful. Actually, this type of glass facade is very common. It's very decent, very lucrative, but very difficult to make because this is a very new area. This facade is not included in our BNBC. Actually, in Indian standard or in that there is nothing stated about the facade. But in Delhi standard, they made not new rules for only for Delhi. They took this facade in their consideration. In Dubai, they have lot of buildings or the facade, very decent building. And in almost every year there is some fire in Dubai, as per a report. But they designed in that way. Their vertical fire separation is not proper. But they are making it. Dubai has their own standard different. Their vertical separation is less than 2, so that is very difficult. So, but for BNBC 2020, we need to develop or to modify accordingly because a lot of building is moving for vertical separation in Bangladesh. So there are some lot of solutions. All are in research, and most of them are not like that. So up to this, we have to be very careful about the deciding of facade. It's very difficult to design, very difficult to make, but very decent, very lucrative. So you have to be very careful of designing this facade. This is, you have to be particular about this. So whatever I was saying, if the building is detached, so building is separated, then if it is separated with some distance, how much open area we can keep between these two? Here is some option in the BNBC. Is not very detailed. If it is IBC, it have given the detail. If the distance varies, sorry, if it is sprinkler, how much opening area you can keep, how much not you can open keep. But in simple, and BNBC gives some ideas. All openings shall be protected type and shall not exceed 11.2 meter square area, and width shall not exceed of the length. Opening has to be protected. If it is separated, if it is two are separated, there should be some opening because there have some windows, but that window must be by protective, non unprotective, because wall is 2 rated or 1 rated or 3 rated, depending on the hour rating. This separating wall must be protected. So it is related with the fire separation of the wall. If it detached, and I will come again. For fire separation wall having opening shall be covered by automatic fire suppression system. The maximum allowable opening may be doubled when a minimum distance is 0.9 meters. So if you increase the distance, if you increase the detest, then your opening may be doubled. So you have some idea from here. So how much distance you will maintain between these two detached building and how much opening is allowed. But it is an idea, but you can find in the detail in the IBC. Protected opening shall be limited to 5.6 meter square area with a maximum height of 2.5 meter and width of the 2.2 meter. Wall or floor opening shall be protected with approval fire resistant means. Wall or floor. You can think, if it is floor, if there is opening, through the opening floor there should be some opening. It may be opening for the stair. It may be opening for the chute to move from one floor to other. You have to move electrical lines from floor to floor. You have to move plumber pipes from floor to floor. So if you have this opening, if you made some opening, you have to keep some fire resistant means. How this means moves? You can put it close at the floor level, or you can make a enclosure vertically up and then make it close. So opening in floor have protected enclosure or have enclosure walls. So enclosure, protective opening closure, that means at the floor level you can close it, or you can make it up, if we can make it closer walls, which shall be again protected with the fire assemblies. So by this way you can protect floor in this ceiling or in the different floor vertically. So if you have some opening in the vertical direction through the floor or around the floor, you have to make enclosure walls to by fire assemblies. Opening service lines like cables, electrical wirings, telephone cables, the plumbing lines, you need some fire protection. In some languages, it is said as a penetration. not the opening, it says some penetration. In BNBC, we do not define penetration, but in NFPA, it is defined as a penetration because this opening is small. If you think about the escalator, about the lift, that is also a penetration, a opening through the ceiling, through the roof. But that is a big size of opening. We call it is opening. Then it is protected by enclosure walls or some other means, or protective openings, assemblies. That is the big opening. If it is a service line like electrical, plumbing, or all, it is then normally NFPA it is called as a penetration. But BNBC do not say it is a penetration. BNBC use it as opening, but it is a small opening. So you have to understand this small opening as a penetration or a large opening like lift or like staircase. So these are also vertical opening to the floors. So in all the cases, you have to protect accordingly by with protection along the floor or protection along by the enclosure. Now I'm giving some idea. You have already seen that if the building is separated at a distance, then you have to think about the how much distance you are making with the wall to wall, then how much opening you can maintain. You have to maintain. So this you can consult with the table IBC, which is not in BNBC, or other than IBC, you can have it from the NFPA or other code. You can get this type of table. NFPA also have this type of table, not similar table. So you can consult for this. If the building is detached, what should be the opening under the different at the nearest wall of this detached structure? Now I like to talk something about the smoke and heat vents. Actually, when you think about the life safety issues, when there is a fire, the smoke will propagate from one room to another within flashover, within flash after the flashover, or before the flashover. Whenever there fire, smoke will move from one room to another. If the building is not proper design, the smoke will go to the stair. So you have to restrict this smoke propagation, and not only the restrict propagation, you have to allow the smoke to go out. So you need some vent so that smoke can go out. So normally you have some ventilated area, whether it is naturally ventilated or mechanically ventilated. If it is naturally ventilated or mechanically ventilated, so smoke you can remove from this area. But those area which do not have ventilation, that is called the restricted ventilation area. That means the area where air cannot move very easily. That is the restricted ventilated area. You have to remove the smoke from that area. So you need some vent so that smoke will be released out. So it will not accumulate inside the building. So in case of fire, there will be no accumulation of smoke and the people can evacuate very easily. When exit access travel distance is more than 25 meters, smoke and heat vents shall be constructed. So this is the one thing you have to construct building. But from first thing is you have to give ventilation to the you have to give the vent for the restricted ventilation area. And the second thing is if the travel distance is more than 25 to 20 meter, you have to give a smoke heat vents so that there will be no accumulation of heat and smoke. The vent area spacing of the vent shall comply with the table 421. I will show the table 421. So depending on that table, you have to give some spacing of vent. So actually there is a lot of parameters you have to consider. That all I cannot show in this presentation. I am giving some few points which you will consider. You have to see a little bit detail for that one. Closure of natural draft smoke and heat vents shall be installed in such a way that Fire service personnel can open it easily during a fire. Smoke and heat vents on roof or ceiling or wall shall normally be kept open. Not open, shall normally be kept open. So you have to think that way that this will be open. In case of closed vents, automatic automatic activation of the opening by heat is a sensitive device above the ambient temperature shall be required. So vent will remain closed. You have underestimated before, but at a certain temperature, it has to open. So how it open? There are two type of mechanism. Another is at the right of temperature, it will melt down and it will open, or at the certain temperature, it will automatically activate by electrical switch or by spring switch so that it will open. So this is the releasing mechanism. Some releasing mechanism you have to put in a vent. That is the difference between the other ventilation and this type of vent. Other ventilation, particularly in the normal that is open, that is natural or that is open or closed, keep it. But this type of vent, which is now we are talking designed, normally it is open, but normal, but it is, if when it is not working, it is closed, it will be open by some activation mechanism. That activation mechanism will work on the temperature or on the sensation from the smoke. The vent shall have a capable of being opened by normal manual means. Whether I put it automatic sense or not, but it must have something which we can do mechanically. The vent for industry and storage is a very deciding factor. That will be differently talked, and that will be given appendix B, which I talk when it will come in the part 4. That will not consider for this lecture. It will be considered in the second lecture. That will be, I will give in detail about the vent, how we design vent for buildings, particularly for industry and storage. These are some area of vent area you see, depending on the occupancy type and the hazard condition, the ratio of vent and the floor area and the maximum spacing between the vent to vent all are written here. Whenever you design, you have to take this from here, the values. Now I like to something very little about the electrical gas and HVAC system. That is not detailed here in the BNBC part 4. This is a very small area. So the detail is in part 8 that is referred here. So you can see the requirement of electrical, HVAC and gas service shall meet the previous of the provisions for the part 8, which is very detailed in there. So I will not give some, I will not talk nothing about it here. All you will learn when it is coming here. Just one thing is the vent and duct for air conditioning and vent for duct for here for smoke propagation. Everything has to be controlled perfectly because the same vent, same floor may be used by both. But you have to remember that when there is a fire, all HVAC system will be off, but this vent, particularly the mechanical vent, must be on for removing smoke. So you have to be very careful while designing this vent by air condition and vent by for smoke and fumes at the time of fire. So the electrical connection will be very difficult for these two because you have to control all these two. One is during fire, another is as a normal condition. Another thing is fire for air conditioning duct. You have to flow the air flow. You have need to flow air, hot and cool air through the duct. But during the fire incident, all flowing air crossing from one floor to another has to be stopped. So if you like to stop, you put some damper according to need, which floor air you like to move and which air you do not like to move. So you have to be very careful about the ventilation, air conditioning, and the smoke ventilation system. All these ventilation system has to be designed simultaneously, and operation will be very critically. Another thing for large assembly areas, departmental store hotels with more than 100 rooms in a single block, effective means of preventing circulation of smoke through the air conditioning duct shall be installed having a smoke sensing control device. So you have to be very careful about the designing of these areas, assemblies of this. So you need to consider smoke sensing is in a different way, particularly for large hotels and departmental stores. That area is different. We have already talked about the surface finish. This again, there is a definition of surface finish in a different way. Previously, there is a way on defining in the surface finish. Now is again a definition differently in putting in the BNBC. So it is again a definition of surface finish class 1, class 2, class 3, but it is the same meaning with a different approach of testing. This is the testing method is different, but all the same thing. Here is the testing is the moving, is the measurement of the flame front from the initial to at some point. And so it is the similar thing of the definition, but it is different in the BNBC. Almost similar definition, but in a testing process is a little bit different. So this is again the same thing. How on what is up on the building type of building, the type of surface finish you are using. It is type you see that for D1, A1, A2, A3. There you can use different type of material. So one thing you have to remember: type 3 is a very easily combustible. Type 1 is non-combustible. That means if you choose a type 1 material, that is the flame is not moving very fast. It is lowest type of moving, but when it is heat resistance. But if it type 3, it is not heat resistant. It is the fast moving material where fire can move very easily. If it is 3, fire can move very easily. If it is 1, fire cannot move very easily. Fire, that means flame or fire, whatever you say. This is something with the glass assemblies. Actually, in BNBC 2020, glass assembly, it means it's a windows or doors or skylights. That of thing. It does not consider facade glass. It is all for glasses, uses for glasses, uses for windows, glasses used for separation, but it is not glass for facade. It is for door glazing. There are two types of fire rated glass. One is white glass and another is electrocopper plate, electrocopper glazing, or there is some equivalent type. Normally, this type of glazing can be used. If you like to make a protective type of glass windows, you have to select a particular type of glass for different fire rating. If you do not need to protect for unprotected glass windows, you can use any glass type of it. So you have to remember two things: whether you making a protected type of windows or doors or unprotected type. It will be unprotected. You can use any type of glass assemblies of a particular thickness. So there is some size of opening which is only size restriction, no restriction about the fire rating. But if you want to make a protective windows, then you have to choose fire rated glass, that is a wired glass or electrocopper glass with particular type of fire rating. There is some thickness limitation. You should not make less than 6 mm thick, or whatever you make protective glass, you have to make the glass assembly as a whole fire protection your fire. So if you like to make your fire detective window, you have to protect this as a whole. Here are some wide rating opening size depending on the. So you see that the 3-hour fire rating. So you cannot make a glass panel of 3-hour fire rating, but this is BNBC. But now people are making glass of 3-hour, 2-hour fire rated. So there is a very special type of fire rating of glass which is rated 2-hour, 3-hour up to, and in some cases very specially made glass is available on the 4-hour rated. Very expensive, very highly protected, but it is very difficult to make a fire rated glass. So normally we get a glass fire rated is a one of a half hour to 1.5 hour glass, and their size and openings are like that. You can, if you like to make some opening with the fire rated, you can take the data from here. Similar thing with the skylights, and you can choose the size and the thickness of the glass and some other fittings with the glass. You have to choose all the fittings accordingly. Now I like to talk something about the fire lifts. Actually, fire lifts a very deciding factor because we are now using a lot of high-rise buildings without lift. These like buildings doesn't kind of work. So you need to put a fire lift. If you have lift, you must have a fire lift because during fire, fire lift is especially designed by used for the firemen, not all for all occupancies except hospital or other occupancies. At the time of fire, all fire lift will be not working by the normal people. Fire lift will be operated by the firemen only, and normally all other people except firemen, they do not use, they never should use fire lift. But at the hospital, you must use the fire lift because some patients who are living upstairs for their evacuation, they need the lift. So there must be a special provision for fire lift for hospital. If it is high-rise fire lift, there is very special type of fire lift, especially designed that will be installed for the patients. For other type of occupancies, fire lift is normally designed for firemen, and that will have particular type of capacity, 8% capacity, and that has a particular type of speed. That means from top to bottom within 1 minute it go from top to bottom. It has to traverse, and it has some voice communication, two-way voice communication. It must have some other standard criteria, particularly one criteria. There should be all lift outlet door at certain distance. There will be a smoke detector which will detect the area or the floor there is a smoke or fire, such that the lift while moving by firemen, it will not stop at that floor. So a fire lift must have some this type of facility. Another thing, a lift bank should not have more than 6 fire lift at a time. Another thing, fire lobby and the lift and the stair should not be in the same, if not totally protected. If it is separately protected, a fire lift should not be built around, a stair should not be built around the lift. If it is built, the total lift and the fire stair must be protected as a closure, fire protected as a smoke-proof enclosure. The speed or you have is all lift in the tall structure, hospital or accessibility shall be operable during fire. Lift lobby shall be connected with at least one of the fire stair by means of exit component. So these are all about the fire lift. You have to very careful about the designing a fire lift, and you have to not on the design, you have to be careful about the operation at the time of fire, and it varies depending on the type of occupancy. You have to be careful about that. Now there is some provisions depending on the type of occupancies, provisions for using utility service. Utility service means the utilities that like kitchen, like water supply, like electricity supply, like boiler. These, if like gas supply, depending on the type of occupancy, you need some special type of limitations. So every occupancy have is different type of uh, utilities and differentiable conditions. So it is occupancy to occupancy, it is different. So you have to be careful when you are using utilities for different type of occupancy. For example, for residents, the flammable liquids for domestic purpose shall be kept adequately sealed within the limit of exempted quantity. You have already learned in part 3, if there is a flammable type of material, like for oil, like for diesel, like for anything, depending on the type of flammability of the material, there is some exempted quantity. Exempted quantity have two parameters. One is exempted quantity in a open form, or exempted quantity in a closed form, in a packaged form. So depending on these two, you can preserve in your utility areas to store this type of flammable liquids in your occupancy. So again, I am repeating the same sentence again. Depending on your occupancy, you have different types of utility materials which can you store based on your exempted quantity. In the exempted quantity, you have a table. There are two parameters. One is amount and the type of way you are keeping it. You can keep it in an open area, as an open unit, or you can put it in a packet or in a chamber. So depending on these two, there is some different quantity, and you can use its amount, and you have to put in a particular area in your occupancy. So depending, you have to some table. If you are designing your occupancy for the residence or other, you have to choose how much quantity you can preserve and what is the area you can put it. If you think about here the door of the room containing flammable liquid shall be provided with self-closing device. All outdoor rooftop antenna shall be protected by proper lighting system. So these are some utilities area. Depending on the type of occupancy, you have to design your occupancy and the utilities. This is residence. If it is education, you have chemicals, you can volatile materials. So you have gas lines, you may have boilers. So you have to put in different tray in the different protective areas. So this is totally variable depending on the type of occupancy and type of material uses. So here is some area, some values. You have the main points I have written here. So now there are a lot of other parameters you have to go if you need to actually design for that, because depending on the type of occupancy if you think about the healthcare, in the healthcare you have some medical gas, you have some oxygen, some nitrous oxide, some carbon dioxide, some helium, some compressed air, some ethyl alcohol, some chloroform, some methylated spirit. You have a lot of things for medical as well. So you have to be very careful about the using of this area, and you have to use this in a control areas. So again, there is a term I use not to now is a control areas. Control areas means the area which is properly protected. Properly means depending on the type of materials you have to protect. You have to give fire barrier. You have to give a smoke barrier. By UNV, depending on the type of material, it will vary. So if it is oxygen, if it is a chloroform, the type of protection is different. So your control area is different. If your kitchen, that is also a control area, you have to different is different. So depending on the type of material, type of occupancy, your type of material is different. So your control area will be different. Your packing system will be different. So you have to accordingly you have to pack it everything. So it is exam. So again, so if it is industry mercantile, you have to be very careful about this liquid fuel, everything. You have to be some points, but detail you have to go again to the BNBC. Here is not all point is given here. Here are giving some points just for idea. You have to be careful about this type of hazardous material. You have to use as a utilities depending on the type of materials. But you have to be careful about the hazardous areas, equipment and machinery in operation, ignition, and emitting combustible volatile substances shall be installed in a standard environment as recommended in the NFPA or equivalent standard. So you see that it is directly referred to the NFPA for hazardous material, because detail is not given in this BNBC. Actually, there are some detail which is not given in the BNBC. It's a code, so in the code, all detail cannot be given in it. Room containing boiler or heating plant shall be effectively separated from the main occupancy. This is the only line it is written, but it is effectively separated from the main occupancy. This separation means separated by walls, or sometimes it may be detached. Particularly, it is saying if the boiler is fuel burned or with electric burned. If it is fuel burned, it has to be it has to be detached. If it is electric burned, it can be inside the room, but again there will be some limitation of the, but you have to be effective. So here it is said effectively separated. So you have to be very careful this effectiveness of the boiler. Again, I repeat, if the boiler is electric heated, you may allow it is within the building, but very far from the exit routes, egress system. But if it is fuel burned, it has to be outside the building. It shall be, as per BNBC, it shall be outside the building. If it is fuel burned. So I am ending with these three things. Actually, detail is in NFPA, and as per BNBC, it is not have given. It is given if you like to have garage, you should go through the NFPA, and that is the start of NFPA for the garage. And then other occupancy utilities, you have to go again NFPA, and for miscellaneous building, you should get NFPA. So you need detail of this miscellaneous building. Actually, miscellaneous cannot be defined. You can have a different type of building. So for detail, you have to go for NFPA. For example, for actually if it's a station, if it is a macro station, bus station, then you have to go NEP 130. Actually, we should, nothing is given is a BNBC. If you like to design, now in Bangladesh, there's a metro service going on. If you like to design a metro station or anything, you have to consult with the NAPO 130. Just for example, I am talking that. So this type of special miscellaneous buildings should be consulted with a special arrangement and a special provision of the NAPA, nothing said with the BNBC. Now I'm going for the chapter 3, which is the means of egress. I have left on another 45 minutes, so I like to finish within, I hope I will finish this chapter within definite time. Means of egress is a new language which is not in the in BNBC 2006. Means of egress is widely used in NFPA. In the, BNBC 2006, we use means of escape. The means of escape and means of egress similar but little bit different in combination. Now in 2022 we use means of egress. I will show the definition of the means of escape also. A similar thing, but means of egress has different meaning, different combination. That is the difference between the combination of egress is different, but almost similar in language, in meaning. Means of egress is an NPA using means of egress. Means of egress is a continuous, unobstructed way of exit from any point within the building to the refuse or to the exit termination. In the same language, same meanings of the means of escape, but the egress has a different combination, which is that egress has three parts: exit access, exit discharge. So egress is little bit a very elaborate explanation, elaborate description how when a fire incident happens, the way a occupant from his own point go to the exit discharge. That means the safe way where he is standing. That is the outside of the buildings in some defined area which is totally safe. So egress means a starting point of any people on the building from anywhere to the outside of the building, on the road or on the courtyard, the safe yard. That is the total length is the means of egress. The total means of egress we divide in the three parts. One is exit access, exit and exit discharge. This is highly requirement for a fire safety dog. Actually, this is the main life safety area which you have to be very careful, because at the incident of fire, a person has to move in this way so that his life can be saved. This is the path of evacuation of any point from the people, so that a people can go outside of the incident. Within a few minutes, he has to go outside for his life. So this is a very deciding area, deciding thing. Then you have to be very careful about the means of egress, and you have to be very careful about the design of means of egress. And this is the path of movement of the occupant through which he can way out safely to the outside. So first I would say the exit access is a path of evacuation from any point of the fire affected area to a protected entry around as an exit to entry. From any point to entry in the exit. If entry is finished, that means his exit access is finished. That means a door, that is the termination of a movement of a person to a safe door. From door to the outer exit is the exit. From some entry of the door, or it is the fire door, or it is normally it is a fire door. The outside of the fire door is the termination of the exit access, and inside of the door is the start of the exit or start of the exit. And that sometimes exit is a door, sometimes is not only a door, a landing, a stair, and in end of a stair, then the exit, then that is the, after that is the exit discharge. So sometimes a exit is the entry of the door, fire door, and then a long distance of walk. If it is a high-rise building, from the floor, he just start in the first staircase entry, that is the start of the exit, and the way through the staircase and out of the building, up to out of the building is the exit, and when he is out of the building, that is the exit discharge. So exit may be a single point or single plane, well, it is very easier. It's a single plane which front is the inside the building, and the out of the exit is the staircase, or a safe area, or refuge area, or horizontal exit. It can be anything. So that is the start of the exit, and finally the exit discharge. So the exit is the exit access, then the exit, and the exit discharge. If I take the travel distance, that is the exit access. So what are the what are the combination of exit access? Exit access consists of corridor, passageway, ramp, balcony, doorway, smoke and fire enclosure, compartment, fire stair, or any combination of these. This is the total exit access, exits, and horizontal exit shall provide a delay egress. Receiving areas are capable to accommodate expected evacuee for certain time period. These are free from heat, smoke, and aggressive fire from area of incident, and shall lead to the exit discharge without returning the evacuee to their initial locations. That is called horizontal exit. And generally, lift, accelerators, and moving walks shall not be regarded as a component of means of generally. It is not, it is generally, but there are some special case until they are designed specially to include a component of the means of egress. In that case, the fire lift will be designed such that the fire lift can be used as a exit. Means of escape, a way out of the building or structure that does not conform to the formation of the means of egress, but does provide a safe way out. That is exit means. So any way, if you can way out, that is a means of escape. So that is not a combination of egress. So that is different, little bit different, but it gives you a way out. It gives you a way out, and anyway, that is the means of escape. There are some general requirement of designing consideration. Only one source of when designing a exit access, you have to think in the building there is one fire. If it is more than one fire, you cannot design. So this is the limitation of the design. Every design has some limitation. Here we think in the building there is only one fire. All construction material by qualities and quantity shall be approved type. Stability of a structure element or building itself shall be as per this code. Occupants, rescuers, and firefighters' life safety shall be the prime consideration. I repeat, life safety shall be the prime consideration. Fire suppression, extinguish management for life safety and minimize property damage. So you understand, fire suppression, extinguish, that is the secondary. that is that minimize the property safety. That is not for life safety, but that is a minimization property damage. That is not the main life safety issues that minimize the poverty. Provision of this part shall be the minimum standard. So whatever I talk about this standard, about the Egress system, that is the minimum standard. You can go up to any value. That is the requirement of the owner of the building. But this, up to this, you have to follow. You shall be followed for designing these things. All buildings or control areas or storage shall be provided with the adequate exit facility. Exit shall not be used for any other purpose at any time that would be obstructed, tended. But in Bangladesh, it is a normal thing. There's some obstruction in the way. Particularly in industry, people use for other use, for other type of use. Where corridor or passageways or components of exit shall not be used to supply or return air. Understand? For the exit access of all exits shall be clearly visible. Corridors and passages for leading to the next exit discharge shall be marked and signposted. Levels of walking surface in the means of egress shall be 1:20. Ramps or stairways shall be used in case of change in elevators of walking surface. Abrupt change not exceeding 130 mm, not exceeding 60 mm shall be held in 1:2. A stairway in the means of egress shall consist of minimum 2 steps. Tread depths do not less than 30 min, and a riser shall not be exceed 230 mm, but shall comply tread and riser combination. There are a lot of other points also. I just put some of these points here. This is not all. So these are some few points. Whenever you like to design, you have to read more carefully, more detail. Exit from any room or space shall not open into adjoint or intervening room or area except where some adjoining room or areas in the accessory to the area served is not an hazardous. In some buildings I have seen that there is some fire stair, but to go to the fire stair you have to pass through the kitchen. This is a design. Actually, behind the kitchen there is a common space in a building where there are a lot of family in a building. Normally they want a common fire stair. In the design, the people put all fire stair in such a way that you have to pass through the kitchen. That is the wrong way of design. Just for example, I am saying this. That is the exit from a room. Space shall not open into adjoining or intervening room or area except where some adjoining or areas in the accessory to the area sub is not a hazardous. In a room, in a family room, particularly in the living room, in the resident room, kitchen is the most hazardous because there are gas, flames, or other things in general. So when leaving from the room for the fire stair, you should not design such a way that you have to pass through the kitchen. This is just for an example of the which is commonly used in Bangladesh in different areas. No portion of the exit shall pass through a room that may be subject to lock. This has happened particularly in the institutions. You be careful while designing this exit so that it should be in the room. It should not pass through it should not be locked All entry points to the assembly occupancy shall be served as exit and shall have the total capacity for at least one half the total occupant load. So you have to be careful about this exit. Every exit should have that capacity so that half of the population can pass through any exit. Provision of exits shall have capacity to evacuate at least one third of the occupants from each level. So before it was says from the same floor, now it is saying in different floor. Particularly in the assemblies, 2 or 3 floors are accommodated. In the high, they use the different levels for construction assemblies, particularly in theater, in auditorium, they use different levels. All exits shall be so located arranged that they shall provide continuous and unobstructed means of egress up to the exit discharge. Continuous and unobstructed way. Sometimes when I'm coming from the top floor up to third floor or fourth floor, then they change the stair. They gave a horizontal movement, then giving a different stair. It should be avoided. It should be avoided. So it should be normally it should be if you use a fire stair up to a certain limit, you are using fire step from, as for example, 6th floor to 4th floor or 5th floor. Then somebody changed the horizontally from that stair to again another different stair. Now they allow the horizontally movement. Then again another stair, fire stair. So it is always suggested that so then you can move continuously. You can move continuously. So it shall be located and arranged such that they all shall provide continuous and unobstructed means of egress up to the limit. Sometimes it is happened, so you have to keep it in mind that it should be like that. It should be discharged totally. Now this is an example of what is exit access. This graph is taken from other picture of an FPA. So you can see this is upper level. The left one is upper level. The right one is left one is discharge level, where you have discharge from the all floor cannot discharge to the access. If it is top, then second, then third, then if it is ground level, then you have the discharge level. So the left one is a discharge level, right one is upper level. From upper level, you have to from any point you are going to through a exit to the stair case, and there is some elevator which is separated from the exit. So from upper level, by through some stair, you are coming down to low level, ground level, or discharge level. From discharge level, you have to go out to the discharge point. The discharging. So from exit access means from any location. That means the all together is the blue. You have to come down and to the discharge level, and the discharge level you can go out because you have some exit access. In the discharge level there is a horizontal axis, horizontal separated by wall. You can see thick wall, thick red line, that is the high rated wall. So there is in the discharge level there is a horizontal axis. In the top level also there is a horizontal exit, but on the upper floor there is no discharge level. So from top level to from top upper level at the point of exit, you exit starts, and then in the staircase in the lower level the exit again continue, and up to the discharge there is the exit access. So, you can see here the exit and exit access. So exit starts for the upper floor from their staircase, and it will continue up to the exit discharge. The discharge floor, the exit starts from any room to exit to the stair, and after the stair, the exit starts. The exit access, again, if I read this, the exit access includes the room and the building, a space people occupy, and the door assembly, aisles, corridors, unclosed stair, and unclosed SAMs that are traveled to reach exit. That is the exit access to reach up to the exit. Then the exit on the discharge floor. So the top figure is the discharge floor. So if I read from the written, on the discharge floor, exit includes the following: 2 door assemblies from the corridor directly to the outside at the grade level. So you can see in the blue line, 2 door assemblies from the corridor directly to the outside at the grade level. Horizontal exit, that is vertical extension of or similar to the horizontal exit located immediately above on the second floor. So horizontal exit from top to bottom, upper floor to lower floor. Exit passage that connects one of the upper floor exit stair enclosed directly with the outside and is separated from the remainder of the discharge floor. Rated barrier including fire protection rated self-closing door. That is the exit of the upper floor, sorry, discharge floor, and the lower picture, you can see the blue line. Upper floor exit includes the following: 2 exit stairs enclosed by fire resistance rated barrier, including fire protection rated self-closing door assembly. Then horizontal exit consisting of a fire resistance rated barrier, including a pair of fire protected rated self-closing cross corridor door assembly that completely divided by the floor into 2 fire components. One thing you remember, in the upper floor, in the right corner, you see some stair, a spiral stair. Remember that if the occupant is more than 3, a spiral stair is not a fire stair. A spiral stair, again I repeat, if a spiral stair is used for a fire rated stair, the maximum population will be 3. If it is more than 3, no spiral stair can be used as a fire stair. So each corner there is a spiral, but that is not a fire stair. Exit discharge. The discharge floor exit discharge includes the following. First thing is here, exterior space giving a reader exit door assembly in the exterior wall continuing to the public way. Here, exit door in the exterior wall, 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 and continuing to the public way. Continuing to the public way is a exit. Okay, and then the exterior walk along the side of the building, beginning at the door assembly from the exit passage and the continuing to the. This is exterior wall walk along the side of the building, beginning at the door of the assembly from the exit passage, the door of the exit passage, and continuing to the public way is the exit way. Last one, interior part of the travel from the upper floor. Travel from the upper floor, exit discharge through a portion of the discharge floor corridor. Here, exit discharge through a floor of the corridor. Here, through a floor of the corridor, then go out, then it will be the exit discharge for the upper floor. Actually, for upper floor, there is nothing here, exit discharge. From here, it is exit discharge. One here, on here, on here. And here, you have to go down and then you can find a discharge. Here, you cannot see anything discharge. Here, only the exit. No discharge here. Here, you have the discharge. One, one, and this is one, three. Occupant load. Design occupant load for which component of means of egress to be provided shall be highest number of the occupant per as stated below. The actual number of occupants for whom the area served by the exit is designed. The number of occupants shall be computed as per prescript table 431. The number of occupants in area shall be computed as above in all. The computed or design occupant load shall be summation of the occupant of a space and the evacuee or other space. So occupant means occupant in a floor, or occupant, somebody is coming from outside through horizontal exit through this egress system. This is the total occupant. So total occupant that will be served by the exit component considered, that is the actual occupant load. This is the occupant factor. You see that for residential is 18, for healthcare it is 15, and so on. There is the occupant load. But one thing you have to remember in Bangladesh, particularly in garments factory, the occupant load is much, much higher. That means density is much more. In that case, they do not follow the BNBC. Actually, at this moment, there is a labor law. Labor law says similar thing like if you see the industry here is 10 gross. Actually, 10 gross, it is meter square. But in the labor law, they says 10 meter cube. That means actually that is due to the human comfortability. You need a air per person is 10 meter cube. If I divide by the height of the building, it is 3.6 for industry. It becomes about 2.6, 2.8. As per labor law, it is 2.8, and that is followed by the garments factory at this moment is now. So if it is 2.8, actually the all garments factory can follow this rule, but actually this occupancy which is given here, this is not at this moment garments factory is not following, but it is acceptable as per industrial law. It is acceptable as per accord, as per Alliance and Expert. There is a book written for this garments factory as a NTC guideline book. In that book, it is given a concession for the garments factory. Actually, this data for NFPA, this data is from BNBC, is not suitable for the particularly sewing floor of the garments factory. It is good for the NFPA as far this factory is a high density factory, is a general type of factory. That's why garments factory needs some special documents, special recommendation for this density. If this density is 10 meter per a person, a garments factory cannot run, because a person when working in a sewing machine has to hand over his product to the next person by moving. But if it is 10-meter gap, a productivity cannot be done. Actually, that is not correct as per NFPA also. So for the garments, you need some special consideration. That's why as per BNBC, you need a performance-based design. Though it is G for 10, but it is not acceptable, particularly in the area of sewing factor. In other than sewing factor, it is fine. But if you think about the gross area, if you consider the toilet, bathroom, and other areas, or their fooding area, their veranda, if you think, then it is relaxed. Again, it is 10, it's high for the garments industry in Bangladesh. So there is some concession other than this one here. These are some data for the assemblies. Assembly have a lot of other data also. Here is some few data. I like to move quickly here because assembly has different combination, different details. All is very special for assembly. Type of assembly is totally is different. So that's why I like to sweep faster. For assembly, you need lot of other parameters, type of assembly, type of seat, type of fixed seat, type of mobile seat. There are a lot of combinations you have to read very accurately for that. Here is some table which gives you a maximum requirement for a stair depending on the type of occupancy, the width of a stair, ramps, doors, and all of that are here. If it is sprinklered or not sprinklered. If, as for as example, if it is residential, your stair is 8. If it is a ramp, it is 4. If it is door, it is 4. So you can see a stair is just double of the door. Always it is double, almost double. So it is almost double because if we consider the people coming from the upstairs, always the stair have more than double, almost double population than the level on the door, because from the door some people will come outside of the wall and go the stair. In the meantime, people from the upstairs will come, so there will be much. They need much more area. Normally, if we think about the sequential evacuation, 2 floor will be coming at the time. So that's why it is considered almost about double in this in different ways. And you can see the different data for a corridor passage and all exhibits. So you can see everything here. Assembly sitting, it's also you see some exception. Always there is exception, written exception. Actually, for very assembly, you need lot of other parameter to consider here. So there is lot of exceptions in this data. So it is better to quick move it to one. For doorway again, you need some separation for doorway. You have to design a very special door for with the fire rating. You need fire rated door. And for moving out, you need direction of flow. Depending on the number of population, direction of flow is different. If there is any flow, there both direction people will move. You need double door, double lift door, so people can move on the both way. So depending on the type of population, it is when and if the number of people is more than 50, you have to be the direction of flow, opening a direction of flow of the door must be in the flowing direction. And the door has the different other parameters to consider to move. So now in different in the Mercandish assembly or in the assembly, you need revolving door or different type of door. So if it is the revolving door, you need some other parameter to consider. The number of occupation, speed of the revolution, some parameter will come. So you need a lot of things for enjoy. For a stairway, there are a lot of parameters you have to consider for stairways. Every step, there are other parameters, and particularly for curved way or windows, you have to be careful about the number of population. Normally, windows is not permitted in the stairway, fire stairs, but with the limiting number of population, you can use it. A similar thing is spiral. But we have a lot of parameters, particularly the similarity of the height, similarity of the trade, and this width, handle. Lot of parameter you have to be very careful about it. And the width of the landing and the door opening in the landing and door size of the funding landing, you have to consider lot of parameters which has restriction of this stairway. Because stairway is another thing is and another thing is the slippery of the stairway is very mandatory, because when you come down, the angle of your wood is changes, so there is every chance of fall down, and you have to be careful about this friction factor of the material of the floor. So in Bangladesh, most of the you are using tiles, so you have to be careful about the friction factor of the tiles. If it is zero point 0.3, people will easily fall down. If it is zero point 0.5, then people will survive. So normally the slipperiness of the tiles, when it is glazy, it is less than 3, particularly when it is water. So you have to be very careful, because when people coming down, then there will be some sprinkler can on, or some hidden water can come from anywhere. So there is every chance of fall down. So you have to be careful of the sleepiness. But it is not written in the BNBC, it is in the NFPA. Your floors slippery must be like that, it people don't fall down. The value friction factor value is 0.5 for non-slippery, or value 3 is very slippery. So you have to be careful of the slipperiness. The material we use in the tiles, it is less than 3 always. If it is glazy, if it is non-glazy, it's fine. Particularly in the we use in the toilets, the tiles which is not slippery. You have to be careful over the stair. These are some restriction of the values of the stair, the limitation of minimum width of this stair. Here is the values. You have to be careful about the minimum values because there is every chance of pushing in the floor. I think this is a highest scale stairs. There is some value, the minimum size for more than 10 people is one, but then less than 10 people is a little bit different. But one thing at the note, I think is the wrongly written. You can read that later, right? I'm very scared about this line. I'm not sure about this, but it is written here. The maximum design occupant load for a fire escape stair shall not be exceed 50. I think it is 50. Somehow it is wrong, because already you have given data for less than 50, one less than 50 people, two opening, one opening, less than 500, two opening. If it is less than 200 people, two opening. So these does not match, because it's a 50, you need 10 opening. 500, you need 10 stair. If it is 50, if it is if cannot exceed 50, for 500 people you need 10 exit. But you have already written that there is for less than 500 you need 2 exit, less than 1000 you have 3 exit, more than 1000 you have 4 exit. This is the restriction already written in the BNBC. But if you think if it is 50, it will be very difficult to make the building. So I think somehow this is my idea. It may be not true. So you see this horizontal exit. So you have to be very careful about the horizontal exit. So it's a safe area, but at the same level. Expect for enclosure, you need a 4-hour perspective. You need vegetable. For a stair, you need a vegetable, open area vegetable to save the building. If it is high-rise building, there will be 4-hour fire rating for expect for enclosure. These two you have to be careful. And for the exit enclosure, you need fire pressurization, particularly high-rise building, and fire pressurization must be with the 50 PA, 50 Pascal. So for a smoke-proof enclosure, all exit of the building must be smoke-proof enclosure. You see the number of exit you have for the building. This 1, 2, 3, 4, which I have already called travel path. But for travel path, you have to see this is the for travel path. You see this is the some figure how you calculate the distance travel path. Normally, with people distance we means the only perpendicular distance, but travel path is not a particular distance. In NFPA, it is raised travel distance. For BNBC, we use two words. One is travel distance, another travel path. And because it is written in that way, because distance means a perpendicular distance, but actually we mean the actually length the human has to traverse during evacuation. So whatever it is said in the NFPA, it is travel distance, but for BNBC, of travel distance, we mean travel path. But so in BNBC, we use two words. One is travel path, travel distance. So travel path is measured in that way. You can see from here. So if you see this figure, so it is travel distance, travel path. So how each travel path is measured? It's from you say at the middle line, and the middle line, and you say if it is not fired dot, then up to here it is travel distance. If it is fired up to this, it is travel distance. So you have to be. This is the fired dot. This is not the fired dot. This is the variation. If it is the fired dot, up to this is the fired travel path. If it is fired dot, this is the fired travel path. So from the same distance, from any point to same distance is the travel path. So there is some restriction of travel path. You can see here that's another parameter is a travel path and some common travel path. So there is some common area. So there is some restriction of the common path also. So there is a table. So you can see that there is a travel path, travel distance, how much you have to travel depending on the type of occupancy, it varies. So from for designing, you have to design a travel path distance that is the maximum value. Remember, the travel path value is the maximum value, maximum distance. Normally, whatever BNBC says or the minimum value, but for this case especially is the maximum value. So maximum number of distance, maximum distance you can design it for a travel path. This is final illumination. You have to be central. If exit, you can have all exit should be when if illuminated. All exit should be illuminated by light. Two light. One is itself, another is the second power. One is what that's so two light to be operated by two power. So there is some appendix that is all the design of fire plan, how a drill is conducted. Particularly, a drill should be conducted as per FSCD certificate, Fire Service Civil Design Certification, and fire drill is to be conducted by regularly. And during fire drill, you have to very careful about the fire drill. It has to be done. It to be done occasionally and regularly without any notification. And fire drill during fire drill, you have to give alarm sequentially. Total building should not evacuate at the same time. So it must be sequentially, and giving the alarm, you have to remember the alarm sound should be 10 decibel much more higher sound than the area of noise. Okay, thank you all. Thank you for listening me. Thank you all. Assalamu alaikum. Now it's the time to have question. Mahmudul Hassan Himal, occupancy type A2, A3, A4 seems different from the Bangla text and English text. Please clear me. Actually, there is no Bangla text. Bangla text means it's a Imarat in one Bidhimarat, that is not BNBC. BNBC is English one. Actually, English and Bengali is different because Bengali is a Imarat Bangla Nidhimala. It is written on the top. It is Imarat, that is in Bengali language. In English, it is a BNBC. So this confusion is due to you are reading two different. Actually, it is said, when I talk it, I said, this is Imarat Bangla Himala, which is used in Bangladesh. That is not BNBC. That is only for understanding. We have in Bangladesh, we have two type of Vidhimala we have to follow. One is Imarat Nidhimala, another is Bangla BNBC. So there is some deviation. I told you there is some deviation in Bangla in English. Then in Habibullah, when someone attended the seminar and quiz also, but he and she did not pass marks, that I cannot answer because passing depends on the ICC.
I think you skipped one question. If you scroll up, there was one question above that.
Up.
Yes. So there was no. You went a little down, little below. So here, yes, if you need 3 hours separation
In the different occupancy category, we have to design the separation top floor, slab, column, according to higher fire rating. What is the question? If we need to 3 hours separation different occupancy category, we have to design the separation top floor, subfloor, higher floor. Yes, definitely. If it is 3 hours, you have to design. You have to actually you give the table. In the table, you say it is, if it is 6 inch thick, that is 3 hour rated. If the floor is 6 inch thick, normally all floor 5 inch or roughly 5 inch thick. If you want to make it a 3 hour, you have to make it 6 inch. And if it is facade, it is very difficult to make it, because vertically it is almost zero. In that case, it's a new idea. We call it is a perimeter separation. Perimeter separation. Perimeter barrier separation. There is a new thinking that is called a perimeter barrier separation. By perimeter barrier separation, we can separate the floor from floor to floor. That is not included in BNBC. That is the new idea is coming in with the coming of this facade. This facade is a new idea. Last 10 or 15 years, Bangladesh, Haryana, it is not included in the BNBC. So you can do it by vertical height of the slab or by perimeter barrier separation. There is some idea. So you can do that. Is it permitted to use fire lift without fire occurring time? Yes. Yes. Is it permitted? It is permitted. It is permitted. Always, if fire lift uses, at that time fire, it will controlled by the fireman. Only at the time of fire. Normally, it will be used. Normally. How we can, this is a question, how we recognize the fire rating of 1 to 3 hour of garment factory? By thickness. By measuring thickness and the content of this separating wall, you can decide which one, 1, 2, 3, 4. If you measure the thickness, if you find this, whether it's a brick or is it concrete, then you compare with the table, you can find this. So if you measure the thickness of the wall, and if you find this, what is the composition of the material, then you can, from the table, you can find this, what is the fire rating of that. Could you please share a standard format for evacuation plan? At this moment, I don't have. Actually, it varies. There are a lot of plans I have seen. I can share with one. I have one. It is written, but it is not a format. It is a fire plan. But I will discuss a lot of things about the fire plan. I will talk with you in my next lecture about the fire plan. So I shall try to address your question. For that, for structural fire design, a table BNBC guide asks about material ratio, say 1, 2, 3, 4, 1, 2, 4. This is a structural member. This is not within the fire ratio. But for detail, you can see ASCE 29. It has all ratio combinations. There is all ratio combination. You please go to the ASCE 29. It has all details. It is referred in the BNBC. For detail ratios, you have to go to the ASCE 29. You find all details of this ratio. If you cannot find if you give me mail, I can give you the photocopy of that one if you feel. But ASCE 29 have all detail of this ratio. For performance design, I will talk detail about that tomorrow. For performance based design, I will talk detail about the performance based design. It is in the part chapter 5. So I will talk you tomorrow about the performance design. I hope you will be attend there, and I hope you will be understand that time. Thank you all.